Okay, so the lab setup which we have, it can be accessed from the URL labs.networkgeeks.in, and this will be a login page once you log in. So in order to log into the app, you have to use your mobile number with the country code specified. So country code 91 and your mobile number, and then the domain as @ng. And the passcode is something which you will get from your NG mobile application. So once you have your credentials, you can either use native console, which requires VNC and PuTTY to be installed, or you can use your browser console. So you don't have to install any additional apps. All the consoles will be opened in a browser tab. So we will go with native console. I prefer to go with native console. And then once we sign in, you'll be landing at the root directory. So at the moment, the Fortinet labs are placed under ng free lab. We will move this to a separate folder. So once you select your lab file, you will be able to access your lab topology. Now, in order to start, we will build this lab setup topology, and then we will share the lab access with you so you can practice what we are going to, the topics which we go through on day-to-day basis. You can practice the same thing in our lab. And to start the machines, just right click and start. And also the configurations will be set. So when we start the lab, at the initial stage, there won't be any configuration. So to access the console, just click on it. You will get the console. Let me share my screen once again to share the console. So let me show it once again. So in order to access your console, just click on the lab device and you'll be able to access the console. It's booting up.
Recording ending.
Okay, so once we get the device, we can log in. So the default will be password will be admin, but it will not allow you. There is no license. There is no any configuration done at the default stage. So in order to import your licenses into your lab, so you have to click on this import config option. This will redirect to another page and where you have to log in again. The login again is the same, your country code along with the mobile number and the domain @ng, and then your passcode from the NG mobile application. So once you log in, you will get an option to import. So this import option will be available when the machine is turned on, and it will be available only for the devices which we have set to import. So in our case, for PCs, we don't have to import any configuration. Only for the firewalls, we have to import. So at the moment, I have turned on the perimeter firewall and a configuration has been set to import. So once you import the configuration, okay, I have turned on. So there is some configuration. So let me wipe it out. So just wipe the configuration and then import it. So once the config is imported, you'll be able to log into your firewalls, and the username will be admin and the password will be test@123. So let's try that. Okay, so let's try with admin, and the password will be test@123 and T will be caps. So once we log in, we will be able to get the license status, get system status. Okay, and the license is valid. So the way how the license, we have imported the license to this firewall, and once the firewall is connected to the internet, it will be able to validate the license. So in our current lab setup, this particular element, that is network, connects to a local router in our DC, and from there we have internet access. So if you want to provide internet access to any of the devices in lab, you can use this local this element network that will help you with the internet access. But don't connect any PCs to the internet. Always only use the lab devices like firewalls to the internet, because we have a set number of NAT pool available. Guys, please be mindful of your microphone. Okay, so these are basic elements to basic way to import and get started with the lab. Now, in today's session is basically an introductory session. We are still expecting more people to join this training. So we are only going to discuss very few basics about firewall and the evolution of the firewall, and where to place a firewall depending on the scenario. Some of you must have attended the boot camp, so you might have gone through this topic in the past. So please consider this as a refresher for what we have discussed in the boot camp. Okay, so I hope my screen is clear for everyone. So the firewall which we see today, it has a history. It evolved over a period of time, and starting with packet filters. So since in the early 1990s, the firewalls which we used, they are not powerful as what we call as firewalls today. They were merely a packet filter. When we say packet filter, they are mainly working as a router and switch. They don't have any capability to read into the packets. They cannot inspect the layer 7 of the traffic. They can only do layer 3 and a limited layer 4 inspection. So they work basically by looking into the source and destination IP address, and then the source and destination ports in the TCP. That is how the early stage of firewalls were working. Then, but the problem is, these firewalls are called stateful firewalls. So in stateful firewall, you have to write rules for every direction. So let's say you have a firewall in your network. So when it comes to stateful firewall, let's say you have your LAN and then your WAN. So in the policy, in the firewall policy, you'll be having one set of policy which says any connection or a specific connection from inside to outside, you have to allow this. And there'll be a second rule which will say any connection coming from outside to inside, and this has to be allowed. Now, what is the reason for this second rule? We don't use this second rule nowadays. It's used because the earlier firewalls won't be able to remember a session, or it won't be able to build a session. Nowadays, when we when we use the firewall, the connections, the sessions will be based on the session tuples. I will discuss the session tuples later. So using the same sessions tuple, the firewalls which are available today, they were able to send the traffic back in. But the earlier stages of firewall, that is packet filters, were not capable of this. So to improve on this, then came the stateful firewall. So stateful firewall, again, its capability is very limited. It is very good at performing the lower layer checks, but again, the stateful firewall is not capable of performing any layer 7 inspection. So it uses 5 tuples. So the tuples values are, let me write it down. So the tuples will be source IP, second will be destination IP, and then the third will be protocol number, and the fourth will be source port, that is TCP port, and the fifth will be destination port. Now, this tuple implementation can vary with respect to the vendors. For example, if you consider Palo Alto as a firewall, it also uses the source interface or source zone as one of their tuple in certain scenarios. So the tuple implementation, it varies with the vendor which you're working with. But in FortiGate firewalls, these are the 5 tuples which is used for any matching scenario or any session building conditions. Now we have the capability to build the session based on the stateful. In stateful firewall, we have the capability to build session based on the 5 tuples. Now, the advantage of having this session table is you are limiting the number of rules. You don't have to write rules for in and out. Firewall itself can use one rule to send the traffic in and out. So this is helpful in terms of security as well, because now you have more controls, and firewall itself can understand, it can predict like what traffic is going to come back. For example, if there is a SIP traffic, a VoIP traffic, after the control connection, when the actual data traffic comes in, the data will come in a different port. So firewall will be able to analyze expect the sessions, expect the port number in which the return traffic is going to come in, and then it can allow those connections. So such capabilities are available only for stateless firewalls. So the stateless firewalls evolved from stateful firewalls. Then comes the application firewall. In application firewall, we have the capability to inspect layer 7. So when we say layer 7, it has, again, the capability is not as powerful as what we have today. It has a limited capability. So it is capable of understanding any decrypted HTTP traffic or SMTP traffic, but it acted more like a in-point solution like IPS filtering or web filtering. It's not like a firewall which we have today. So it was more like deployed like a separate device which is capable of doing application filtering. Even nowadays, some architectures will have such kind of deployment. Then only after early 2000 came the UTM firewalls. So these UTM firewalls will combine the capabilities of the earlier application firewalls along with stateless firewalls. So it can have much more granular control. So UTM stands for Unified Threat Management, where you can inspect the traffic and you can identify if there is a threat. Early stages of certain firewalls were not able to identify the threat or the malware in the packet. They were only able to do filtering based on the rules we configure. For example, only if you configure a destination as a malware destination, any traffic going towards this destination will be blocked. But when it comes with UTM firewalls, they were capable of inspecting the traffic and identify if there is any malware in the traffic. Now, the limiting factor for the UTM firewall is they were not capable enough to handle a huge amount of traffic. What I mean to say is the throughput is not very efficient because there will be multiple engines within the firewall. So the same traffic has to be sent back and forth because UTM firewalls were just put together with it's a combination of application and stateless firewall. So it's not a feasible solution, or the product has not matured enough to handle a good throughput. Only when the enterprise firewalls came in, that is late 2016, when the enterprise firewalls came in, they were specifically designed to handle the throughput and to combine the powers of UTM firewall and stateless firewalls. And the firewalls which we see today, that is enterprise firewalls, otherwise known as next generation firewalls, these are the one which is capable of inspecting the traffic, identifying a malware, and at the same time provide a better performance throughput. Now, where do we place this firewall? Nowadays, now we have this enterprise firewall, a powerful device. Where do we place it in a network? Let's discuss that. And the placement of this firewall, it depends on the scenario. One moment. Okay, I hope my screen is visible for you now. So, uh, in today's network, we generally categorize the network setup into five different ways, five different types. One is distributed firewall, another is cloud firewall, then the next generation firewall, then the data center or DC firewall, and then the integrated segment firewall, or we call it as ISFW. Now, if you notice one thing here, all these different type of firewalls they are also referred as next generation firewalls. I mean to say the capability is same as the next generation firewall. Then why do we have this five different types of deployment or layers of deployment? For a typical switch or router, we follow the Cisco three-layer approach. Even today for the LAN segment, we follow the three-layer approach. But when it comes to firewall, along with the three-layer approach, we have to consider where we are placing the firewall and for what purpose we are placing the firewall. But just by defining these two factors, where and what purpose, we can easily choose what kind of firewall we want to use. Even though the is capable of doing all the functionalities, we cannot use it in a way. For example, if a firewall is deployed in a DC, we are expected it to have performance. Now, if I turn on certain features in the firewall, which is going to degrade the firewall's performance, there is no point using that firewall in a DC. So we will discuss those details here and one by one. So first, let's go with distributed enterprise firewall. So distributed enterprise firewall is nothing but it's designed to protect large and geographically dispersed locations. For example, uh, KFC, Domino's, Royal Enfield. These are certain entities. They have their presence all across the world. For example, if you consider India, they have their locations in many states, many districts. So in each location, you should be having a firewall to protect their setup. Now, let's consider a typical KFC outlet, which hardly has 3 to 4 PCs or maybe 5, 6 PCs. Then they have their Wi-Fi network for customers to access Wi-Fi. And then they have their POC machines where the point of sales where the transactions will happen. Now, in order to protect these machines, you don't have to have a firewall which has a throughput of like 10 gig or 100 gig. A firewall with a 10 gig throughput is capable enough to handle the traffic coming from 6 PCs and a couple of POS machines and then the Wi-Fi routers. So the firewall which you deploy in this stage, it will also be a next generation firewall, but the CPU and memory of this firewall will be limited to handle only a certain level of traffic. But if you ask if it can do the high-end functionality, if it can participate in the can we configure it to perform decryption? Yes, we can. Can we configure it to perform UTM inspections? We can. Can we configure these firewalls to perform uh, layer 7 inspection and then do layer 7 natting, then do this expectation sessions for SIP and VoIP traffic? Yes, we can do. Can we use these firewalls to multicast traffic? Yes, we can do. So the capabilities of this distributed firewalls is in par with the very high-end series. But still, you will not choose a high-end series to be deployed in a distributed fire location. That is at a small office location. Please excuse me. And another advantage or another use case of this distributed firewall is where these firewalls will mostly connect to your home office or your DC location. So these firewalls should be capable of configuring and maintaining a VPN connection to your DC so that you can connect all your resources in your remote locations to your data center or your home office. So these firewalls which we deploy in distributed network, they are capable of doing all things, but at a limited scale. And the another main requirement is for them to have VPN capabilities. Now, if you consider Fortinet solutions, Fortinet has firewall models like 30D, 30E, and then it goes to 60 EF D series, then 80D, and nowadays we have 90 D series. So 91E, 92D, these are the latest models. So anything that starts with a two-digit number in Fortinet is considered as a low-end device. And if you check the physical appearance of these devices, these are like tabletop firewalls. It has like 4 to 8 Ethernet ports, one management port, one console. That's it. It's very limited. It might or might not have its own dedicated uh, fan for cooling. And if you see the power supply of these models are like laptop chargers. So typical 5 volt DC charge laptop chargers is what's used for these kind of models. Now, once let's say now enterprise, an organization has all these remote locations, and they might be having some application servers or any database that is running in their environment. Now, for redundancy purposes, they might run it in the cloud, or if they wanted to have this cloud availability where application will always stay up, they will go for cloud deployments. Now, when you have a firewall deployed in cloud, it's not that your deployment is safe and secure. Still, you have to deploy a firewall in your cloud to protect all your servers which you have. So this is where the cloud firewall comes in. Now, this cloud firewall, these are not physical firewalls, these are virtual appliances. So when you purchase any cloud licenses from Fortinet, you will be purchasing the licenses for the number of CPU you want to bind for your firewall. You are not limiting your firewall based on the memory. The memory of your firewall is not tied up to your license. The license which you purchase from Fortinet is only for the number of CPUs you use. So if you purchase a firewall license for 10 core CPU, Then in your AWS or Azure, you can allocate 10 core to the firewall. So you can use this firewall again to protect all your servers. You can also maintain VPN connections with them. And in terms of performance, the throughput is not limited by the firewall or the VM instance or the license which you use. The throughput of your cloud firewall is 90%. It's dependent on the server in which you're running your VM. So, for example, if you enable DPDK in your cloud firewalls, your performance will improve because DPDK skips the mid-level format that is running on the server. So, whatever VMs we are running in the cloud servers, they can directly access the packet from the NIC of your physical server. So, in that way, the performance will improve. Now we have this all the enterprise, all the distributed offices connected to our cloud firewalls using VPN. Now, let's say you have your perimeter firewall or your home office or DC location in which you have your exit node. So, or your core layer. This is where your next generation firewall comes in. So this next generation firewall, beyond the traditional firewall inspection, it can also do it can do application aware inspection. Then it can do a deep packet inspection, SSL or SSH decryption. So all these capabilities can be performed by this next layer generation firewall or your perimeter. So if you're deploying a firewall in your perimeter, your main focus is security, not the performance. You have some concerns about your performance, but your main focus here is security. So you will implement all your layer 7 inspections here, your deep inspection, malware detection, IPS prevention. Everything will be deployed in this next generation firewall. So in this layer, you are expecting a throughput of 1 gig to 40 gig. So if a firewall has to perform such kind of inspection, that is 1 gig to 40 gig throughput, within Fortinet solutions, you'll be using a firewall, anything that is in the series of 4. That is, you have firewalls in the range of starting from 1,000 all the way to 4,200. So these models, anything with 4-digit model, you will be using uh, in your perimeter layer. That is your next generation layer. So these firewalls are capable of providing throughput till 40 gigs. And at the same time, the CPU is powerful enough to handle all the layer 7 inspection. Now, another expected feature out of this perimeter or the core layer is where all your VPN connections will terminate. So if you deploy this in your main branch or your home location, all your VPNs, when we say VPNs, your IPsec VPN, your SSL VPN, users connecting from SSL VPN, all those connections will be terminated on your perimeter. So these firewalls should be capable of maintaining such session. So if your user count, let's say if your number of users connecting through VPN is in the range of 2 lakhs, then you will go with 4 lakh 20, 4,200 series. So which is capable of handling 2 lakh VPN channels. But if your VPN is like 10,000 or 20,000, you'll be starting with 1,000 F series or 1,800 F series. So those models you'll be using in your core layer. Now, once your core is set up, then comes the DC firewall. So the main purpose of DC firewall is not the layer 7 inspection. The main purpose of DC firewall is throughput. So these firewalls are capable of performance or providing a throughput till 1 Tbps. There are certain models like chassis models, which we call it as 6K. So FortiGate 6000 series or 7000 series. These have much different architecture compared to normal firewalls. So this 7K is called as ET ETAC. So it's some not ETAC, ETCA, something like ETCA architecture. So these are hot swappable models where you can physically remove a certain blade, a certain component of the firewall out, and you can insert it again. So some of you might have seen this or might be aware about these kind of models where you can physically remove a certain CPU or insert a new CPU. You can remove a disk and insert additional disk. So such capabilities will be provided by 7K series. And then we have 6K, which is not hot capable, not hot swappable, but again, it's a very powerful device. It has close to 120 CPU cores, and it's a very powerful device. And the throughput of these devices will be in the range of TBps. So you will deploy such firewalls only in places where your main focus is throughput. So when it comes to data center, you are focusing on the throughput because you have all your application servers, your replication servers, your database servers, everything in your DC. And users accessing your DC servers, they want seamless connectivity. They don't want any latency. So in such conditions, you'll be using higher end series like 6K or 7K for your DC requirement. Then you have your internal segmentation firewall. This is where your actual users, maybe your office users, your LAN segment users will comes in. So the reason why we nowadays we deploy internal segmentation is to prevent your east-west traffic. In the early stage, a threat, the threat vector is from north-south. All your threat traffic, most of your threat traffic will be coming from your internet. So that is the north-south traffic. But nowadays, a threat can also come from your internal segment. So that is the reason nowadays the best practice is to implement the internal segmentation firewall, where you will segment your firewall in a way for different floors or for different departments, for different business entities. You will have their own internal segment firewalls. Now, these internal firewalls will again be connected to your DC firewall, or they'll be connected to your core firewall. There will be a connection between your core and your internal segment. But the purpose of this internal segment firewall is to prevent your or protect your east-west traffic. The reason being, if you consider the typical Cisco three-layer architecture, you don't want it's the same concept where you don't want all your internal traffic to be sent to your core and then use your of core firewalls capabilities and then to send to another switch and to your network. You want to prevent your capacity or your performance in your core. So for this purposes, you have your internet segment where all the east-west traffic can be inspected by respective firewalls. Now, in this picture, in this pictorial representation, you have it says multiple firewalls being deployed here. It doesn't has to be a multiple physical appliance. Uh, Physically, it can be one firewall, but logically they'll be separated into multiple firewalls. In FortiGate, we call this concept as VDOM. We will discuss this VDOM topic. We have it in our schedule. So using VDOM, you will split your single firewall into multiple virtual firewalls. So you can assign certain memory, certain ports to each virtual firewalls, and then you can make them function as different firewalls. Now, another thing is this internal segmentation firewall is where all your Wi-Fi access points or your internal switches will comes in. So if any of you have gone through FortiGate Fortinet deployment, They also Fortinet also sell access points, Wi-Fi access points, Wi-Fi controllers, wireless controllers. So all these will be connected to your internal segmentation firewall, and from there the traffic will traverse through your core. Now, when it comes to performance, the typical performance expected out of this internal segmentation firewall is in the range of 10 Gbps. They are capable of handling this, and when you check the Fortinet's available hardware models, the typical firewalls which you deploy here, they will be in the range of 100F all the way to 800 or 900 series. So anything with three numbers, you will be deploying it in your internal segment. Anything with four numbers, you will deploy it in your perimeter level. Anything with two number, that is 30 to 90, you will deploy it in your distributed firewall setup, that is your remote offices. And anything with 6K or 7K, you will typically deploy this in your DC. Now, some customers or you might deploy even the 4200 series in your DC. 4200 is capable of handling your data center, but it depends on your traffic pattern. So it depends on your capacity. You can decide like which model you'll be using. Let's have a short Q&A session here. So anyone has any questions in this deployment models? If you have, please feel free to unmute yourself or drop the question in your chat.
Hi, Arvind. Arvind, I have a small doubt.
Yes, Arav. Yes.
So you are talking about the throughput, right? So throughput in the sense, what and all parameters we need to consider on the throughput?
Okay. So what are the parameters you want to consider for throughput? Let's say you have your application server in your data center, which has maybe it stores some 5 TB of data, and you have like 50 users or 500 users trying to connect to this application server. Now, you can, if your network is configured for, let's say, 1 Tbps links, all your internal segment is capable of 1 Tbps. You will be splitting this 1 Tbps with all your 500 or 5000 users.
Uncle.
You will be splitting this 1 Tbps link with all these users. So even though your physical link is capable of handling 500 TB, 1 TB of traffic, your switches or your routers and firewalls, they are not capable of that. What I meant to say is, even if you're using Cat5 or even if you're using optical fibers in your LAN segment or between devices, your devices are not capable of handling that. So that is what we mean by throughput. So if your requirement is 1 TB, then you have to and let's say your requirement is 1 TB. Now your physical ports on the firewall is not capable of 1 TB. So what you will do is you can club together multiple 40 gig interfaces. So there'll be 40 gig interfaces, and if you club together 3 or maybe 4 link for redundancy, if you put this in LACP, you will get like 160 Gbps. So this is what we mean by throughput. So if you consider any firewall in your distribution layer or your internal segmentation layer, these are not capable of this 40 gig. Only the firewalls which comes in your core layer or DC layer is capable of this 40 gig. There are also firewalls which has like 100 gig interfaces. So if you will be clubbing together those 100 gigs into LACP, and then you will take care of the throughput. Did I answer your question, Arav?
Yeah, a small doubt here. So throughput in the sense, it will be consider only the level of the traffic, right? So it's not about with the processing of SSL inspection or app ID.
No.
Not
It's
considering the CPU level.
So when you say SSL throughput, that is the throughput you're expecting in your SSL connection.
Okay.
So when you say, if let's say I am expecting 1 Gbps throughput in my SSL connection for my VPN connection. So to support this, I should be having a ISP link which is capable of 10 Gbps, and the remote user or your remote location should also have 1 gig to maybe 5 gig, or let's say consider the remote location as 1 gig and your home office have 10 gig. With this, you cannot expect like you will get 1 gig GBP, 1 Gbps of throughput. With packet loss, with latency, you will get somewhere around 850 to 950 Gbps. Sorry, 850 to 950 Mbps.
Okay. So suppose if we get a requirement for building a firewall setup, and suppose if the customer says we'll be having a throughput of 1 Gbps, so they didn't mention anything regarding with the service and all. So they're
Mhm,
generally saying about the traffic level what they observed, okay, in their WAN
mhm,
interface.
mhm.
And in that case, how do we select an firewall model?
Okay, so if you go with let's say 90G, that is a small model device. So 90G it will have a 1 gig interface, correct? Or a 10
Okay.
gig interface. Now you can use that interface, and 90G is capable of providing 4 gig or 8 gig throughput in SSL or in UTM. But your ISP connection should be capable of handling 1 gig, and your remote location or your remote user should also have a connection which should provide 1 gig. Now, you are not expecting all your users to have 1 gig throughput. Let's say if you are expecting 1 gig throughput, and if you have 100 users, you'll be dividing 1 gig with 100 users. If you have 500 users, again, you'll be dividing 1 gig with 500 users. But when you say firewall to have 1 gig performance, firewalls from 90G or even 100F, they are capable of handling 1 gig, but your ISP connection should also support that.
So here, 1 gig in the sense it will allow only the traffic processing, right? So in that traffic processing, it has to do with the layer 7 inspection, SS inspection, and it has to do with IPS and IDS and all, right? So
Yes,
suppose if that features has been enabled, so it will consume some part of CPU. Okay.
yes.
So what my question is, suppose if firewall is hitting with 1 gig of inbound traffic, so
Mhm.
how it will divide the how we need to calculate the CPU level
Okay,
and the
so
memory level.
throughput is calculated by the data rate by divided by seconds, correct? If I remember correctly, that is the definition for throughput. So let's say a firewall is capable of handling. Let me clear the screen. Okay. Let's say firewall is capable of handling 8 Gbps. This is the firewall's let's say datasheet datasheet throughput. Now you have you have some traffic. Let's say you have a 10 sorry equal amount of traffic. Let's say you have 8 gig traffic coming from your LAN segment. Now, this 8 gig traffic, if you're suspecting it to SSL inspection, uh, this will degrade your overall 8 gig to maybe 7.5 gig, because the reason being the firewall have to spend some time to decrypt this connection. So the more time it spends, the more the more throughput comes down. Now, how do you decide the time it spends on the decryption? This is dependent on the CPU cores. So if you have more cores, uh, you'll be having a much better performance. So you cannot so when you select the CPU cores, you'll typically be selecting the firewall models. Depending on the model, your CPU cores will come in. So some models will have 36 cores, 32 cores. Some models will have 16 cores. So that is how you will choose it. The
Okay.
more CPU, the more better.
Whether we have any formula like one core can handle this much of capacity of throughput. Is there anything like that?
No, there is no formula which says one core can have this much of traffic. There are ways you can modify which traffic goes to which core, but
Okay.
it is not advisable for your production setup.
Okay.
There are ways you can configure the firewall in a way specific traffic should go to specific core, but it might impact your performance because firewalls are designed to load balance. Let's say you have a 16 core CPU. Okay. It's not that all your traffic in this core 0 is reserved for management, but rest 1 to 50, you have other 15 cores which is available for your data processing.
So
So
management in this sense, like taking the management session up.
so when we say management, it's not only the GUI or CLI access. So let's say a firewall have to start a particular daemon, a function. Let's say you are enabling routing, you're configuring routing in your firewall. Firewall have to start the routing daemon. So that will be taken care by your core 0. Let's say uh, you have your in firewalls we have a daemon called init. That's the first daemon which will start. So this init daemon will be monitoring all the other processes running in the firewall. So this init will be handled by core 0. So anything with respect to firewalls internal management as well as external management will be taken care by core 0. Now this doesn't mean that core 0 will not handle your traffic. Let's say there is no SLI sorry GUI or CLI access to the firewall. No one is logged into the firewall. Your core 0 is completely 0% usage. So some traffic will be given to core 0 for processing. So the firewall, the FortiOS code, it will decide which core to handle what kind of traffic. It will always load balance between all these available cores to have better performance.
Okay. Suppose if core 0 is busy and we are initiating a management session and the core 1 or 2 is free, it will also take core 1 or 2
No,
is not free, right?
no,
No?
no. Your management access is always tied to core 0. So if core 0 is 100%, you will not get console, you will not get GUI or CLI access to the firewall.
Okay.
That's clear?
Suppose if we face that scenario, what we have to do to take a management?
So Uh, Arav, so this scenario will happen if there is any bug in the system.
Oh,
For
okay.
for some reason, if the for example, I'm sorry, this is going too deep. Let's say for some reason your soft IRQ is too high.
Okay.
For some reason, maybe some misconfiguration or some loop in the network, your soft IRQ on core 0 is too high. Your core 0 won't be able to process anything else. I will discuss this soft IRQ in a different session in detailed way. But now,
Okay.
for some reason, if it goes too high, CPU is practically full. It's not able to handle new tasks. So you will not get the GUI or CLI access. So in those situations, we have to identify what the CPU is doing. Now, in order to do that, we have in this scenario, the scenario which you have presented, where core 0 is 100%, no GUI or CLI access, the only option we have is to console into the firewall and to take dumps on the core 0 to see what it is doing, what function it is doing.
Okay.
Yeah, but it's very unlikely. The question which you asked is very unlikely.
Okay. Okay.
It can only happen in corner cases because if even if the core 0 spikes to 100%, it won't stay there. It will come down after some time.
Okay. Understood.
Yeah. I think there was a chat message. So, Gray has a question. I have a 90D model. Can I use it in enterprise distributed firewall setup? Uh, Gray, definitely you can use the 90D in distributed firewall enterprise distributed firewall setup because it's capable of handling it. Let me bring up the datasheet for 90D. Let me share my screen once again. Give me a minute. So this is the 90D series. So it comes with how many ports? 14 ports. So 14 LAN ports. In this, these two ports that are separated here. These are one moment. This let me note this. So one is your console. Two is your USB management. Three is again USB management. Sorry, USB ports. This is to again to take config backup. So let me clarify this. So this port number two, that is USB management. This is for console. You can use it for console, and this additional two USB ports. This is to take config backup, import the image into the firewall for those kind of operations. Then you have your four, which is like a 14 into RJ45 switch ports. Then your five, you have two RJ45 WAN ports. So these ports are designated as WAN in the device. So the reason why it is designated is it has a relationship to the backend architecture. So if you check the backplane, let me see if that information is available online. One moment. 90G fast path architecture. Oh, sorry, 90D. Okay.
So whether each model has a different
Each model has a different. Okay. The documentation is available only for this 3 series models, that is 100 series. Okay, let me show this as an example, if you don't mind. So this is the backend architecture of 90D. So in this, if you see certain ports, it traverses to NP6, that is NP61, and certain ports go to NP62. Now let's say for a scenario, let's consider. Let's see if I can annote. Okay, so let's say you want to build a LACP. So typically you will choose these four ports. Typically, anyone, if you blindly choose these four ports, and let's say you want 40 gigs of LACP throughput. You are, since you have clubbed together four 10 gig interfaces, you are typically you will expect 40 gig, but your backplanes, this is what we call as backplanes. These are not capable of 40 gigs. Again, I'm giving this only as an example. I'm not quoting this to this particular model. This is only as an example. Okay, so please keep that in mind. So your backplanes are not capable. So what you will do is maybe this backplane is only rated for 20 gig. So in such scenario, you will use, let me change the color. So in such scenario, you will select two ports, yeah, two ports from this link and another two ports from this link. So combined using this, you will build your LACP. So with this, you are getting a 20 gig throughput from this link, another 20 gig throughput from this link. So combined, your throughput will be 40 gig. So with all this, sorry, with all this, you will get 40 gig. Just because we chose four 10 gig interfaces on the front panel port doesn't mean like we will get 40 gig. We have to consider the backplane architecture of the model, and then we have to select the ports. So the same thing applies for throughput as well. Let's say you have your WAN link connected here, and if your WAN gig link is like 100 gig, and if your backplane is not capable of 100 gig, you will never get 100 gig in your front panel port. So when you design a network, you have to consider this also. So in Fortinet, I'm not able to find the the architecture for lower series. Let me check here. This documentation is only for 300 to 7000 series. Only for higher end series we have this. Sorry, one moment. It should be available. Okay, here it is. Under NP6 Lite devices we have. So let's say ATF. Let me clear this annotation. So if you consider ATF, if you see, sorry, who asked the question for the 90D? Gray asked the question for 90D. So Gray, I don't. Let me check. Gray, I don't have the architecture for 90D. If you want in the next class, I will find it and I will provide it. But now for the sake of discussion, let's consider this ATF. Now in ATF, you have this dedicated WAN ports. So you can use these dedicated WAN ports, or you can also use your port number 1 to 8. It doesn't matter which port you use. But the only thing is you have a separate link, which is this we call this as Zowie link. In firewall, we refer this as Zowie links. You have a dedicated Zowie link that goes to your NP6 Lite and then to your CPU. Now, why do you want to load all your traffic in a single Zowie link when you have two links available? So that is the reason why you use your WAN port separately and your LAN port separately, so that you can load balance your traffic between two different Zowie links, which is internal to the firewall. This Zowie is not visible for you in your configuration. Definitely, it's visible from CLI in certain configurations, but not from the GUI or not from the front panel port. But these backplane links has to be considered when you choose what link to use. This is not a matter of concern for VMs, and in our training, we will mostly discuss into the VM because we have access to VMs in our lab. But time to time, depending on the topic, I will also touch base with the architecture to what things to consider when we design deployment. Gary, did I answer your question, or Gray?
Yes, you did. Thank you.
Okay, perfect.
I know.
And Nagaraj has a question. Nagarajan has a question. WAN port, how much port speed, throughput versus MTU? So, Nagaraj, WAN port, how much port speed? It depends on the model. For example, in this particular series, that is 80F, 80 or 81F, we have two 1 gig SFP ports, and then you have your WAN port that is two 10, 100 or 1000 base T models. But if you consider some other model, let's say 40F, this might change. So in 40F, there is no shared link. There is one WAN port. And again, it is all capable of 10, 100 or 1000 base T.
And for the default architecture model, it is what 1 gig or more than 1 gig.
Sorry, Nagaraj, please come again. Your voice is not clear.
100 series and the double series, I seen the WAN port is RJ45 model. I didn't see the SFP model. So the WAN port the default speed is 1 gig, correct? So
I'm so sorry. There's some echo with your voice. Can you please drop your question in chat?
yeah, okay.
Thank you, Nagarajan.
I know.
Yes, Manikandan.
Okay, I have a quick question. Can you go back to the data sheet?
Okay.
I think if
Yes.
you want to answer the Nakaraj question, then maybe you can answer me later also. Can you go to specification?
Okay. Yes.
Yeah. So in the specification, we have multiple performance, right? Like a firewall policy, IPS, throughputs, right? So
Uh-huh.
this all each other are complementary, or it's a individual performance for the each device.
Um,
So basically, if it's IPS throughput can go up to 275 Mbps, the parallelly antivirus throughput also can go 65 Mbps. Like, uh, I mean, it's all
no,
adding together, or it's
no. So the datasheet performance which you see, it's a combination of factors. For example, there will be a condition specified here. Not for this model. Let me bring up another model. Okay, you will see it in our latest models very clear. So let's say FortiGate 100F datasheet. So you have some conditions being specified. So under what conditions the traffic is tested and this rating is provided. So it doesn't mean like you will get 1 Gbps throughput for SSL VPN and then you will get another 1 Gbps for SSL inspection throughput. No. So you can take any set of traffic, but in that you can expect 1 Gbps of SSL throughput. Along with the 1 GB, you can also expect maybe like IPS throughput of 2.6 Gbps.
okay. So that's what my question is. Like, if it's a VPN, I understand. Like, VPN have multiple VPN flow is there. But if we compare with IPS threat protection, it's all individual services, right? So if it's
Yes.
individual services, it can use like parallelly. My IPS is also running at 2.6, and my VPN is also running at 1 Gbps. It will work, or again, it will also. I mean, doesn't work.
Okay, I got your question. So what you're asking is, so will I get IPS throughput of 2.6 Gbps and parallelly will I get threat protection of 1 Gbps?
Exactly.
Yeah. So this is a number which we cannot determine because this testing, this IPS throughput testing is done with uh, an enterprise mixed traffic which has application control, NGFW, and threat protection with logging enabled. So that is how they come up with this number.
Yeah, okay.
Now, if you consider threat protection, it, along with whatever we discussed for IPS, it additionally had threat protection with firewall IPS application control and malware protection enabled. So if you combine both IPS and threat protection, you will not 2.6 Gbps, but you will get 1 Gbps.
Okay.
Yeah, because you are combining on top of this whatever you used for IPS. On top of that, you are using your malware protection for threat protection. So we cannot. Maybe some of you might be deploying firewalls or selecting firewalls for deployment. So we cannot go with the datasheet numbers. Datasheet numbers are always tested for lab under a lab condition. Lab traffic can never match with your production traffic because in lab they might use some testers or some uh, traffic devices like SpireNet or for even Fortinet has their own testing solution like FortiTester. They will use such devices to pump the traffic and then bring up this number. But ideally for production, these numbers will not match. You cannot even for IPS, you cannot expect 2.6 Gbps because maybe your application is not the same what they tested in lab. Maybe your application, your custom application might need some additional CPU processing, but you will get more like 2 to 2.6 Gbps. That is what you can take from the datasheet.
So small dot here.
Yes, sir.
So it's not like throughput in the sense it will be IPS plus next gen firewall.
No. You cannot add these numbers. No.
So parallelly, if suppose so then now we can consider the throughput.
Again, when you design, you have to decide like how much throughput you want, and based on that you will choose a model.
Okay.
Now,
Suppose
if let's say you will not. Okay, one moment. Let me reshare my screen. One moment. So we were in the topic of discussing throughput. So when you consider throughput, you will not deploy a firewall. Uh, when you are concerned about throughput, you will not configure your DC firewall to perform deep inspection, because deep inspection is very CPU intensive and it will eat up your throughput. So you will not configure your DC firewall to perform deep inspection. Again, let's say if you configure your perimeter firewall or your core firewall to perform deep inspection, and you have like 50,000 users coming in from your LAN segment or your internal segments, these firewalls maybe it can perform the decryption, but you will not get that desired throughput. So what you will do is you will limit the decryption on your ISFW, or because these are multiple firewalls or single physical firewall being separated into multiple VDOMs. Depending on the user count, you will choose whether to use VDOM or whether to use different physical firewalls. So you will perform all your decryption in your internal segment level, but you will focus on your malware protection or your DOS attack or your IPS signature matching in your core level. That way, you're balancing your CPU and you're balancing your throughput performance. Does that make sense? It's not that we can put one firewall and we can have all the functionalities loaded to it. Its CPU will spike and you will not get desired performance.
suppose in general, if a firewall has a throughput of 1 gig means, so yes, it will include everything, right? Like SSL inspection and IPS, IDS, everything, right? That
But
all service throughput will
it's
be included in 1 GB, or how we
it
can.
includes everything, but conditions applied
Yeah.
under what traffic they have tested and rated it.
Okay, okay.
Yeah, that's a very good discussion we had with respect to throughput. Let me go back to the other questions. So Nagaraj, throughput versus MTU. So Nagaraj, throughput and MTU is not directly related. They are different. So now you asked the question. So WAN port RJ45, is it port? Can you please elaborate your question if you don't mind?
No, the default RJ for the WAN port, the port type is RJ45. But you said that SFP model, but don't see that model.
It depends. It depends on the hardware model, Nagaraj. Some models will have RJ45. Some models will have SFP. Some will have QSFP. It depends on the model.
So RJ45 port default speed is 1 gig or more than 1 gig.
Default speed will be 1 gig, but certain ports you can configure it to 10 gig also.
Okay.
Yeah, if you use Cat5, then on certain ports you can configure to 10 gig also. Yeah. Let me check if there are any other questions. Okay, Arav has a question. Backplane and OVI link are same. Arav, can you explain what is OVI?
No. You were explaining about the black panel, right?
Uh-huh.
So in that scenario, you inform about that OVA link. So
OVI. I'm not following what is OVI.
okay, maybe I would have misunderstood it. You can say.
It's Zawi link.
V link.
Zawi. So it's XAUI. Zawi.
Oh, okay.
So Zawi is nothing but a point-to-point link available in the PCB of your firewall. So these are hard-coded PCB wires which goes through either a Marvel or a Broadcom switch within the firewall. And then it in higher series it will also go with ISF, that is internal switch fabric, where all the
It's
nodes
like
will connect.
this connectivity, yeah.
In terms of networking, this Marvel, it is a L2 switch. And when we say L2 switch, it's a microchip which is acting as a L2 switch, and its capacity is very good. It can handle like very good throughput. But it's not the typical L2 switch we use in our network. It's internal, it's soldered to the PCB board.
Okay.
Yeah. We for normal firewall management, we won't focus into these things. We won't do much. But maybe in some corner cases, if your enterprise setup goes into an issue, you might do some troubleshooting here.
Another thing, so you were explaining about that black pen topology, right? So
Uh-huh.
you said though we have a interface speed, the back pane will have some different amount of.
Yes. Yes.
So how we can check that? Suppose if you said you were aware of the black pane and you said, suppose if you're
So
exploring a new model, how we can find that?
okay. Let me share my screen once again, and let me show that in in the architecture guide. So let's consider NP6 model. NP6 architecture. Okay. So let's consider this 800D for our discussion. So this 800D, it has one ISF, that is internal switch fabric, and then we have one NP6. So between this ISF and this front panel ports, you will be having your Marvel switches, Marvel or Broadcom switch. It depends on the model. We won't be able to find this Marvel or Broadcom from the documents, but from the CLI we can refer this. And when it comes to speed, so you can check this. You can run this command, get hardware NPU NP6 port list. If it's a NP7 device, then you will get NP7 here. If it's a NP6 Lite, it's a NP6. You will enter the command as NP6 Lite and then port list. So you will get the backplane speed. So these are not the front panel speeds. These are the backplane speeds. So for example, port 31 and port 32, they are they are their backplane supports 10 gig. And if you see the Zawi link ID, port 31 goes to Zawi link 0 and port 3 goes to Zawi link 3. So basically port 31 and 32, let me note. Basically port 31 and port 32, internally they are connected with two different Zawis into your ISFW, and each Zawi has 10 gig. Now this port, these 31 and 32, if you consider, these are 10 gig SFP plus ports. So your front panel is 10 gig. Your on the back plane, if you combine them, since they go with the two different Zawi links, you will get 20 gig here. Was that clear?
Yeah, it's clear.
Okay.
Can you come a little bit down
Okay.
that port list?
It might confuse you, but once you go through the architecture diagrams, you'll get some good idea.
One small dot here, just go up.
Yes.
So if you see the port 7 and port 8 are connected to one AVI, which is AVI 2, right?
Yes.
So port 7, port 8, port 9, and remaining ports will 22 will all have black pin of only 1G capacity.
Yes.
So
They all go with one of the Zawi link, and they get 1 gig backplane.
Backplane. So even though each port has 1G, the total capacity is 1G itself.
Yes, 1 gig.
Suppose if you need to build a lag for 2G, we have to form a link between port number 23 and port number 27 to achieve the desired speed.
23 and 27. 23 and 27 goes to the same
Sorry, 23 and
ZOE.
23 and port 7.
Yes, exactly. 23 and port 7. This will give you better performance.
Okay.
Now, it depends on the model. Different hardwares have different architecture and different surveilling. Maybe in this 800D, you have lot of ports in the single survey. But if you
Okay.
consider some other models, you will not see that. Let's say 3100D, you will have, for example, it has 2 NPs. So you have 4 survey links, 0 to 3 in your NP60, and then another 0 to 3 in your NP61. So in total, you got 8 survey links here.
Okay.
So the performance will be much higher here because again, if you see the survey link capacity, it's all 10 gig.
10 gig. Okay.
So depending on the hardware model, this will change. So we are close. We are well over the time. So again, I wanted to, if there is no other technical questions, I want to discuss something else. Let me stop the
I have
recording.
one small technique.
Yes, please go ahead. Yes.
So you were telling about that VDOM, right? So we can
Yes.
the thing. So there is also another concept called VRF. So what will be the difference between this VRF and VDOM?
So in VRF, you are only splitting your routing table, but in VDOM, you will assign front panel interface, you will assign certain gigs of memory, you will even limit how many policies you can write within a VDOM.
Okay.
Yeah.
So we can limit the CPU and the
No,
memory.
CPU you cannot limit. CPU is a global resource,
Okay.
but memory you can limit to a certain extent, yes.
Okay.
And number
Memory
of policies you can
policies.
limit.
Okay. So suppose suppose we have a two VDOM and each VDOM can have a different firmware or it should have a same one.
No. The firmware is again a global concept. So
Okay.
for a box, there is one firmware, but you can have multiple VDOMs.
VDOMs. Okay.
Yes.
Only this
We have a
policy is,
session planned for VDOM, so we'll get some more
okay,
idea
enough.
there. Yeah.
Yeah, I have one question.
Yes.
In the occupancy diagram, it is showing integrated switch fabric. In FortiGate firewall also, we able to see one fabric. So is this same or different?
No, they are different. That is security fabric. This is integrated switch fabric. This is a hardware. Internal switch fabric is a microchip actually.
Oh, it's a chip. Or we
It's
can't
a
say
chip. No, it's a chip in the PCB board.
So this will be used only for switching.
Yeah,
Right?
exactly. Only for
Like
fast switching.
ASIC, which will be used in
No,
the
the ASIC comes here. NP6 is your ASIC. ISF is the supporting component for this ASIC.
No, ASIC for like it is an like CPU or it's a different one.
ASIC is a special purpose CPU. So it can perform certain functions much faster than a CPU. CPU can perform all functions. ASIC cannot perform all functions. It is limited to specific function, and those specific function it can perform in a much faster rate than CPU.
Okay.
So Nagarajan has last question. From SSL VPN, we select ISP interface. That port only considered SSL VPN. Nagaraj, you can use the same interface for your WAN access or firewall access. You can use the same for IPsec connections. It's not limited to specific VPN. You can even configure VIP in that port and you can have different services running in it.
No, sir. Actually, from SSL we select what we have interface. Right. So what we have speed in the internet speed that only considers SSL, correct?
In a way, yes. Indirectly, yes. Whatever speed you get from your ISP, you can use that for your SSL VPN. But you should also consider the SSL throughput of your firewall, because firewall has to build these connections. So again, it's limited to a capacity. Maybe Nagaraj, you will get some better idea about this when we discuss IPsec and SSL VPN in our lab. So at that time, I will show you how the connections are built, how it will be able to process it, and how this offloading will helps in the VPN. When we discuss the topic, you will get some better clarity there.
Okay.
Yeah,
Thank you. Thank you.
perfect. So if there is no other question, I want to discuss another topic. Let me stop the recording.